This is the third video on axial stress, and in this video I'm just going to dive into kind of a corny little design of, say, a diving board. Some diving boards actually have very similar designs as this one, although I would hope that they don't copy me exactly. Anyway, so we have 3 points of concern. First of all, you have point A, you have point B, point C. B and C are supports. A is going to be a point where a load is being applied. That load is from a 200-pound person standing at the very tip. They're not jumping, they're not doing anything, they're just loitering there. So, first of all, we need to know areas. I would say to calculate the stress in both beams B and C, or supports B and C, we need to know the areas. Just to kind of give us an indication of that, I'm going to draw a nice little top view of the board and then the layouts of each support. First of all, support B is going to be something like this. These are two 2x4s. Let's literally keep them 2x4. Don't think that they're actually smaller because of how the wood is made. Let's just literally call it, 2x4. So combined, the whole area of B should actually be 2x4. 2 times 4, 8, times 2, that should be 16 inches squared. Now, let's shade that in. Now you have a different situation. Let's do C. But rather than C being 2x4s, let's just do it a 6x6, like hunk of wood. So a 6x6, like beam, like structural beam. 6x6. Notice that the area of C will be 6 times 6, or 36 inches squared. Okay, so now that we have that kind of situated out, let's go back to our favorite class, vector statics, and figure this out. Figuring out real quick for us, I'm just going to say we have A, you have B, and C. I never really gave us any dimensions up here, so let's do that really quickly. Let's give this, say, 4 feet. And let's give this all the way to the end. Let's give that 6 feet. Okay. So diving back into the vector statics, you're going to have your reaction B, which I'm just going to assume that the reaction B is going to be upwards, RB. And reaction C, RC, is going to be upwards. I'm assuming both of them are upwards. A negative result would just mean it's going the opposite as assumed. We know that's 200 pounds. Okay, well, we pick a point, and we have to make sure that the moment is equal to 0 at that point, or the sum of all moments equal to 0 at that point, because we know that the object is not rotating. So just to give us an idea, I'm just going to consider at B. Okay, we're going to consider point B. So I have to consider, okay, this is going in a positive direction, this is going in a positive direction, so obviously things are going to be changing around a bit. To kind of calculate it out, you have 200, 4 meters away, or 4 feet away, plus you have your RC, and that's 2 meters away. And we know that this whole thing equals 0. Okay, well, to calculate it out for us, we know that RC is actually going to equal negative 400 pounds. Negative 400 just indicates that the arrow should actually be going downward. We don't need to worry about that. Now that we have RC, we can just use the sum of all forces. Sum of all forces must equal 0. Sum of all forces in the y direction, that is. Since sum of all forces in the y direction must equal 0, we can say that negative 200 minus the 400 plus RB, that must equal 0. Well, calculating that out, you can find that RB is actually 600 pounds. So now that we have those two results, we have RC, the reaction at C, is negative 400, and you have RB is 600. What we're going to do is we're going to dive in and actually calculate the stress at points B and C. That's not too difficult. Let's just do that real quick. The stress at B is force over area, which is equal to 600 over 16, 37.5. Now realize that this is PSI. Now, is this in tension or compression? Well, if you can't remember, what you do is you go back and you look, okay, well, the reaction force is such that the ground is pushing upwards, thus the board must be pushing downwards. What does that look like? The beam B, or the support B, is being squished. Being squished, namely, that is compression. So you have actually 37.5 psi of compression. So we could just put a nice little C here, just to kind of, jolt our memory when we come back and look at it. Diving real quick into the final one, you have A, which is going to be force over area, which is going to be 400 over 36, which, calculating that out, is going to be 11.11 psi. And conversely, the reaction force is going to be downwards. So looking at the picture again, C is being pulled down by the ground, thus the board must be pulling up. That is tension. So realize that you have 11.11 psi in tension. Anyways, I hope you found this useful. Please leave any comments or requests for any additional material. Have a nice day.